for as practice, because we're gearing towards that test on Tuesday with a note card. So keep using that note card, because I'll just let you use the note card on Tuesday. I would love for you to just be able to achieve it with the note card at this point. So here's the information they're giving you. They want you to write your own rational function that has these pieces. So they have to have a vertical asymptote at 3. They have to have 2 different holes, -2 and 0, and they have to have a horizontal asymptote at 0. And then they want you to find the coordinates of your holes based on the function. Give me something you know about this function from that list of information. What's one piece that I know has to be in my function? Maybe we could start with just in order. How am I going to make a vertical asymptote at x equals 3? Where in the function does that get put? Look at your note card. So where does a vertical asymptote get put? The bottom. So what factor goes in the bottom so that +3 is the vertical asymptote? X minus 3. Great. So x minus 3 is a factor in the denominator. So far, so good. I checked that off. How can I create a hole at x equals -2? What has to happen for there to be a hole in the first place? Something has to cancel out, right? So what factor do I need so that -2 would be created by a factor? Right? This was +3, so I used x minus 3. If I want to achieve -2, don't I want to use x plus 2? So I need a factor of x plus 2 in the numerator and the denominator so that I have it there to cancel it out. What other factor has to get put in there? I need a hole at 0. How am I going to make a factor so that 0 would be the solution to it? I mean, x plus 0, or I could just write x, right? You need a factor of x over x, because if I plug 0 in here, it makes that factor 0, right? All right, do I have everything I need? This would cancel, but this is my function. Oh, does it achieve this? Does it have a horizontal asymptote at y equals 0? Horizontal. So the power of the numerator, power of the denominator, where's your bigger power right now? Well, not really. This is really x squared, and this is really x cubed, right? So I actually do have a bigger power in the denominator, but that's what I want, right? When the bigger power is in the denominator, that's what I want. So there is my finished product. I don't want to multiply it out. How do I figure out where the hole is going to be? So the hole is after you've canceled these out, right? What would be left? After you cancel out your holes, this would be your new function. So you're going to plug -2 into the new function and figure out what the y value output would be. And then you're going to plug 0 into that function and figure out what the y value output would be. So why don't you finish number 1 by finding the 2 holes. I didn't unpause. All right, so we should get -2, -1/5, and 0, -1/3 for our holes. So let's go on to the back page. I'd like you to try to build number 3, because number 3 is the same process that we just did together on number 1. And then we'll see what you got. All right, I'm going. I want a vertical asymptote at x equals 0. So that tells me I need a factor of x by itself in the denominator, or x plus 0 is fine. I need a hole at +4. So that means I need a factor of x minus 4 in the numerator and x minus 4 in the denominator. So they'll cancel out. I also need a factor of x minus 1, because then when I plug in 1, those cancel out. All right, now I have to answer a question for myself. It says I need a horizontal asymptote at y equals 1. Right now, I don't have that. Right now, my bigger power is in the denominator again. So I would have y equals 0. So I need to create the powers to be equal to each other. I don't want to just add a power of x up here because then that would cancel and make another whole. So I just need to increase the value of one of these factors by like squaring it. I can't really see that, but. So if I have x minus 4, x minus 1 squared, I still have a factor of x minus 1 that's going to cancel, but then I just have another x minus 1 that's going to hang around, right? But at least I'll have a power of x cubed over a power of x cubed, so that when I strip the coefficients, right, of the leading coefficients, I get y equals 1. So that makes it a little bit trickier. All right, so based on my function, if I'm going to evaluate the wholes, these would cancel, these would cancel. I would have x minus 1 left over x. So you're going to plug in your value of 4 and your value of 1 separately and get the output y values for each whole, right? Because originally, if x minus 4 was here, it was undefined at a whole of positive 4. So you plug positive 4 into your new function to generate your output value. So take a minute and generate your output values for those wholes. So if I plug in 4, 4 minus 1 is 3/4 is what I would get. And then when I plug in 1, 1 minus 1 is 0 over 1 is 0. So my wholes would occur at 4, 3/4 and 1, 0. So let me see. Number 4, that's not any different than the ones we've done on the quiz, I don't think. I think I just put these on as practice. And then number 2 looks a little bit more challenging. So let's do 2 together, at least set it up, the function. And then you can try finishing 2 and 4 with your note card. So I don't really like that it's in unfactored form because I think things are going to cancel out. So I need to factor this quadratic and factor this quadratic to see what's going to cancel out. Can anyone tell me how this quadratic is going to factor? What are the factors of negative 15 that add up to 2? Factors of negative 15 that add up to 2. Positive 5 and negative 3, right? So x plus 5, x minus 3, and I still have that x plus 1 sitting there. And then how does this difference of squares factor? X minus 3 times x plus 3. So see how my x minus 3's cancel out? So that's helpful. So the function that you're going to be graphing is y equals x plus 5, x plus 1 over x plus 3. So see where you can get with this function. Don't forget there's going to be a whole at the end because we canceled something. See if you can do your 4 steps on that function and graph it. We could talk about the analysis at the end if you aren't quite sure about this analyze step. You just need more practice, I think. So maybe doing some of those missing assignments, or maybe tomorrow in class when you're doing some extra practice. So let's see, my y-intercept, when I plug in 0, I would get 5 times 1 divided by 3. So 5/3, 0, 5/3 is here. My x-intercepts, I have 2. One's at -5 and one is at -1 because that's what makes the numerator 0. So there's -1, 2, 3, 4, 5. My vertical asymptote is at -3. Vertical asymptote x equals -3, which is here. And then I have to do division because I have a greater numerator than denominator. but you have to be in standard form to do division, so you want to FOIL this numerator out. You really have x squared plus 6x plus 5 divided by x plus 3. I hope some of you are getting better at division. We've been doing quite a bit of division here, so there's going to be a division problem on the test. Make sure you know how to do division. So I put x squared in the box, and I am trying to get x squared. So x times x is x squared, x times 3 is 3x. Now I'm trying to get 6x total. If I have 3x, I need 3x more. That is my 6x total. So I actually don't see the number 6 in the box because 3 plus 3 is 6. So then if I need to get 3x, I need to put a 3. So 3 times x is 3x. 3 times 3 is 9. I don't really care, but the remainder would be -4 to get to that +5. My asymptote is y equals x plus 3, because that is the answer to the division problem. So I'm going to start at 1, 2, 3, and go up 1 over 1, like this. So this is my asymptote. And it looks like I can see the graph already. This elbow must go like this, and this elbow must go like this. So I don't have to do a lot of plugging in. And my last step is I need a hole somewhere on that graph. So what x value is responsible for the hole? If you look back to the beginning, where was it undefined? At what? Where was this guy that I canceled undefined? At 3. So my hole is at 3 comma some number. So I need to plug 3 into this new function. So I would have 8 times 4 is 32 divided by 6. What is 32 divided by 6? 32 divided by 6, 5 1/3. So 3 comma 5 1/3. 1, 2, 3, 1, 2, 3, 4, 5 1/3. It's kind of like here. So see how that should kind of go right through? So there's a hole on the graph right there at 3 comma 5 1/3. So that's a part of your graph that you don't want to miss if you canceled. All right, and the last part says, as x is going to the right, so as x approaches positive infinity, which is this direction, what is your y value doing? Where's this y value going? It's going towards positive infinity, right? It's going up. So positive infinity. And then what about as x is approaching the asymptote -3 from the right-hand side? That's what that plus sign means. Here's -3, and here is the right side of that approaching the asymptote. Do you see how that's shooting down towards negative infinity? So I'm not going to ask a lot of analysis questions on your test, but there might be one of them because we've done it kind of throughout this unit, analyzing the section of the graph. All right, you're here to 11:02. So you've got just a couple minutes. See if you can wrap it up by finishing this last one for the day. There's no division, which is nice. It's just finding, let's even factor it so we know that we're on the right track. How do I factor the numerator? This is a perfect square trinomial that you should recognize. How do I factor that trinomial? Someone help me, please. Factors of 1 that add up to 2? Huh? Nope, not GCF. It's just x plus 1 times x plus 1. How do I factor the denominator? That's difference of squares. Have to know how to factor that. How do I factor it? X plus 1, x minus 1. One of the x plus 1's cancel. So I'm really looking at this as my function to answer all the questions. So see if you can go through your y-intercept, your x-intercept, vertical and horizontal. Why don't we just talk through it together? What's my y-intercept? When I plug in 0, what do I get? plug in 0 for all the x's, I get 1 divided by -1. So -1 is my y-intercept. Okay, my x-intercept. What will make the numerator 0? Say it in your head or say it out loud. -1, right? Can you do it when I'm doing it with you? Does it make sense? You guys just get lost when you do it by yourself? I look at what makes the denominator 0. +1, right? Makes the denominator 0. So x equals 1 is my vertical asymptote. And my last step is comparing the numerator and the denominator. They're the same. So I strip the coefficients of x. 1x divided by 1x is 1. So it has a horizontal asymptote also at 1. So I can see this elbow here. I'll let you off the hook by finding a point. I know it's up here. All right, I just need to find my hole. What did I cancel over here? I canceled the x plus 1s. So that tells me that the hole is at -1. And where is it at? If I plug in -1, what do I get? 0, because 0 divided by -2 is 0. Oh, so the hole is actually at our x-intercept. I mean, not that that's that special, but that's kind of cool. All right, so that's actually a hole. Kind of hard to show, but the hole is actually on the x-axis. And as x approaches infinity, what is the graph approaching? Here's x approaching infinity. What is the graph approaching? What y value? Is it approaching infinity? Is it approaching 0? What's that arrow approaching? What's my asymptote? What's it getting closer to? 1, right? This asymptote is at 1. So this arrow, as it keeps going, is going to get closer and closer to 1.